This is the lab video for Experiment 10, the sodium borohydride reduction of vanillin.
This is the glassware that I've come up with for this experiment. I have a hot plate stirrer, which we're only going to use the stirring functionality of today. I have an ice bath to control the reaction rate, a 25 milliliter round bottom flask with stir bar, Claisen adapter, an additional funnel, and this stem which is holding a thermocouple because I'm going to be monitoring the temperature of the reaction. Now we're going to start adding the contents to our reaction vessel. So I'm going to go out and weigh some vanillin, dissolve it in some ethanol, and place it into our 25 milliliter round bottom flask. So here is vanillin from the chemical stockroom. I'm going to go to the balance now and measure out approximately 10 millimoles of vanillin, which will be around 1.5 grams.
This is the 1.5153 grams of vanillin we're going to use today.
So here is the vanillin. I've placed it in a 50 milliliter beaker. I'm now going to dissolve that in some ethanol. So I've gone again to the stock room and got some ethanol, some reagent grade. I've measured out 6 milliliters in my graduated cylinder. And now I'll dissolve my vanillin in that 6 milliliters. All of my vanillin is now dissolved in ethanol, so I'm going to place that into my round bottom flask. I'm going to rinse that out with a few milliliters of ethanol. And reassemble my apparatus. I'm now going to attach my thermometer to a stand here so that it's not touching my round, so that it is not touching and I will lower this all into my water bath. Lower thermocouple so it's not touching my stirring bar. I've gone to the stock room and I've got some sodium borohydride. I'm going to dissolve that in 1 molar sodium hydroxide and add that to my addition funnel. So now I'm going to go weigh out my sodium borohydride. I'm actually going to weigh out approximately 10 millimoles also, which will be 4 times in excess based on the stoichiometry. So here is my 10 millimoles of sodium borohydride. I have measured out some 1 molar sodium hydroxide, 10 milliliters, and I'm going to dissolve my sodium borohydride in that.
I poured my sodium borohydride into my addition funnel, and I started it dripping into my round bottom flask.
You can see the temperature start to climb, so I'm going to slow this down a bit. And I think I'm going to add a little bit more ice to our ice bath. You can see the temperature has gone down a little bit since adding the ice and slowing the drip.
This is a close-up view of the sodium borohydride in sodium hydroxide dripping into my round bottom flask.
And we've added approximately 1/3 of our sodium borohydride solution, and the temperature is staying steady around 30 degrees C. So we'll continue to add at this rate and monitor the amount of ice in our ice bath. We have added about half of our sodium borohydride solution, and the temperature is now decreased back down to around 25.9.8. So we'll continue adding at this rate for the remainder of the time. And here goes the remainder of the sodium borohydride solution into our round bottom flask. Now that it's stopped adding and the temperature seems steady, I'm going to remove my water bath. And I will now continue to stir that for a half an hour.
Here's a close-up view of the reaction vessel. You can see that there is gas being evolved.
I added a timer to our system here just to monitor the time. It has been about 5 minutes now and everything still looks normal. So we'll continue to let it stir for another 25 minutes. Our timer has gone off. I'm now going to transfer the contents of our round bottom flask over to a beaker. I'm going to rinse that round bottom flask out with a little bit of water. And then we're going to reset up for addition of our HCl. I have now set up for adding HCl to our reaction mixture. I have a new addition funnel. Here is our vanillin sodium borohydride reaction. I've also went and got some more ice because we're going to cool this as we add our HCl. I've gone to the stock room and I've picked up some 3 molar hydrochloric acid. I've measured out approximately 10 milliliters of that. I'm going to add that to our addition funnel. As we add our HCl, we'll be monitoring the pH with some pH paper. Our goal is to have it slightly acidic, somewhere below 6 pH. Here's a piece of pH paper. Let's measure the initial pH. As you can see from that, our pH is very basic, so we're up near a pH of 11. We're now going to start dripping in HCl at a slow rate. You can see it reacting vigorously. I'm going to take a close-up now. I'm going to stop the addition of the HCl and remeasure the pH. And you can see it is still basic. So we'll continue the addition of our HCl. I'm gonna turn off the HCl drip. We'll go back in, stir that up, measure the pH, and you can see it is no longer basic. We're somewhere in that pH 5 to pH 7 range. We're now going to remove our extra HCl in our addition funnel, and we'll dispose of that properly. We'll also remove our ring stand, and we're going to let that chill until it crystallizes out of solution. Well, it's been about a half an hour. I've added some ice in the meantime periodically. And if you look here at the beaker, you can see there's a lot of white crystals in there. We're now going to take that over to the vacuum filtration apparatus and separate the solid from the liquid.
This is just an image of the lab notebook so far.
Here we are at the vacuum filtration system. I'm going to take some filter paper, place it in our filtration funnel, turn on the vacuum, take some DI water that I've chilled to wet the filter paper, pour my liquid down onto it, in through there. And we'll rinse out our beaker with a little water. And we'll now continue to have the vacuum pull on that for a while to help dry it out before going over to the vacuum oven. In the meantime, I'm going to go pre-weigh a watch glass to put our material on. Well, it's been about 10 minutes. I'm going to turn off the vacuum and scrape our product onto the pre-weighed watch glass. And now we'll take that over to the balance and then follow it up by going over to the drying oven and doing a series of
Weighing and baking cycles. This is the mass before going into the drying oven. Our product in the drying oven. The mass after 5 minutes in the drying oven. After 10 minutes in the drying oven. After 15 minutes in the drying oven. And after 20 minutes in the drying oven, and we'll stop here.
Our product is now dried to a constant mass. I'm now going to place the contents into this small vial. I will then take approximately 5 to 10 milligrams of that product and dissolve it in some deuteroacetone for doing NMR. And I will also take it over to the infrared spectrometer and do infrared spectroscopy of it. We're over at the infrared spectrometer. We're going to run infrared spectrum of the starting material vanillin. And we'll run vanillyl alcohol, our product.
Here is our final lab notebook page with all our drying to constant mass data. This is the infrared spectrum of vanillin. And this is the infrared spectrum of our product, the vanillyl alcohol.
Here we are in the NMR lab. We're going to submit our sample into the cube, and we'll come back later today and look at the results on the computer.
Here is an overview of the spectrum that we obtained. I have integrated the signals. I have expanded the important regions of the spectrum. And I also expanded the area associated with our solvent.